everybody who is watching this fantastic video. I'm very happy to have you today, and I'm so surprised. And I would like just to say that welcome into this fantastic moment and fantastic session or fantastic lecture about advanced chemistry. My name is Olenjolai Mokotayai Losingo. Simply just call me Olenjolai. I'm also an electronics and telecommunication engineer by profession. I'm very happy to welcome you today to this fantastic session of advanced chemistry, which is session 4D. Because when I've been preparing this program of the sessions of general chemistry, actually that I've jumped in some of the concepts, and that's what I have to cover right now. So we're expecting to have a lecture for A, for B, for C, for D, for E, for F, for G, for H, until we cover the concept that we have to cover in atomic theory. So I'm from Tanzania, I'm a Tanzanian, and also I'm from Tanzania, and that's why that we are really focusing onto the syllabus of advanced chemistry in United Republic of Tanzania. However, that advanced chemistry is universal. So whether you are a national or international students, you are going to benefit onto this program as long as you get connected and you stay tuned and join me in this fantastic moment. So I would like to take this opportunity, first of all, to welcome you into one of our online schools that called Tanzania Online Advanced Secondary School in square bracket Olenjolai. Sometimes that we used to change OLENJOLAIM, but in square bracket you have to see the word Olenjolai. Simultaneously, I would like to take this opportunity to welcome you into one of our YouTube channels as called Tanzania Online A-Level Set School in square bracket Olenjolai. Well, so the next question is, actually, what are we doing, or how can we help you, or what can we, what problem can we solve in your life? I know that possibly, whether you're a student or a guardian or a parent or a teacher or a leader or a politician who is watching this program right now, I know that many students in advanced educations in Tanzania, in Kenya, in Uganda, in African continents, and even in entire American continents, or in European continents, or Australian continents, or Asia, they are really asking themselves questions on how they can master advanced physics, how you can master advanced chemistry. Maybe you're asking yourself how you can master advanced mathematics, how you can master basic applied mathematics. But well enough, possibly that your vision relies on the need of the knowledge of chemistry, advanced physics, advanced mathematics, and basic applied mathematics. But possibly that you have not got a good place, a comfortable place where you can get actual consecutively and consistently and good organized sequence of learning the materials of advanced chemistry. So, well, we are here, our vision, our assignment, we are here to train and incubate, mentor, teach, encouraging and lead some group of students who will be ready to extract the knowledge and wisdom in advanced subjects, or in advanced science and advanced mathematics, and combine it with the knowledge of the Word of God that we are going to extract from the from the Holy Bible that we are going to discuss, and combine these two knowledge in order to solve real life problems. So, well, the assignments has 4 parts. First of all, extract knowledge and wisdom from formal and informal educations in advanced science and advanced mathematics. Again, we are going to teach you how you can extract knowledge and wisdom from the Holy Bible. And again, we are going to teach you on how you can combine these two, knowledge and wisdom. And the 4th part, we are going to teach you how you can think outside of the classroom. What problem can you solve? How can you use the knowledge that you are learning in the classroom to solve real life problems that really waiting us to solve as scientists or mathematicians of the present age, or whether you are as mathematicians or a scientist of the future age of the next generations, then I know that you are going to encounter some problems which actually have been dedicated for you to solve them. So we have so many departments. One of the departments is called advanced chemistry. The subject of the day is advanced chemistry, and we are focused on the main topic or main chapter 1. That's called general chemistry, because we have basically in chemistry we have 7 main topics, and one of the main topic is general chemistry. And the chapter 1, this is the atom and all about hydrogen spectrum. Hydrogen spectrum, that is a subtopic, and this is session 4D, hydrogen spectrum. That's what we are going to discuss today. These contents are relevant for the pre-form 5 who are studying chemistry, advanced chemistry. Whether you're doing PCM, whether you're doing PCB, you're doing CBG, you're doing CBN, you're doing CBA, all of those combinations need the knowledge of 40 of advanced chemistry. So these contents are relevant for the pre-form 5, for the form 5, for the form 6, or we call them class 13, pre-class 13, and pre-class 13, class 13s, and class 14. That's the relevant. Again, when you go into any schools, any physical schools, I believe even in any online training system, you'll be facing, the first thing that you'll be introduced on is on how you can register yourself. So simply what you are required in these programs, because we are providing these contents free of charge, especially if you visit our YouTube channel. So you just have to have an email. So make sure that you have a Yahoo or a Gmail. You sign in a YouTube, and then when you are there, and then you write just the word Tanzania Online A-Level Circuit School in square bracket Olenjolai. Then you'll see the icons of the national flag, no, the icons of my picture when I was teaching the class. When you click that icons, to send you into my official YouTube channel, where you will find all the contents of advanced education. So when you are there, you will see a red button, buttons with the text written subscribe. Just click this buttons, and then it's going to change color from ready into gray, and even the writings will remain in the same color. But once you click, you'll see also a bell icons. You have to click these bell icons, and then so you'll see 3 options just to choose all. So when you have accomplished it, that's all. That's the registration that you are required to do within for less than a minute. And then from there, whenever we add any new video, because we are expecting to upload more than 800 videos of advanced education in physics, in chemistry, in mathematics, and basic applied mathematics in the same YouTube channel, in order to equip and teach from 5 students and from 6 students, and to prepare them well in order to solve the real life problems. So you'll find all our previous video, and also we are adding at least 1 video in a day. So for you to get notification from the YouTube community, once we upload a new video, we add a new video, then that's why that we ask you to subscribe in advance. Another thing, in case you feel from your heart that you want to offer God your free willing thanksgiving for this program, you're warmly welcome. And then you can just accomplish it by using this telephone number. You see this small box written thanksgiving offering. So we call it Sadaka in Swahili, 0759745331. That's the telephone number that you can send your free willing thanksgiving, and actually to be received with great honor and with great appreciation, and to be used effectively to pay the running costs, so that more videos of advanced chemistry will be in air for the present and future generation. Well, so let us go into the sessions, and then I will give you some other announcement about the reference books that I will be quickly remind you. I insist you, please, before you watch this session, just watch the session written session 00, the general introductions of advanced chemistry for 5 and from 6. You will get too much information there, the overview, the books that you have to go through, and the syllabus of advanced chemistry. So you'll get too much to know as long as you go. But let us go to a quick review of the session 4. Simply, the session 4, it has been written as spectral, okay? So we've been learning about spectral emission, okay? Or we call it, we call it types of spectra, okay? So we've been learning about types of spectra, okay? So I told you about types of spectra. Basically, we say there are 2 types of spectra. The first one is called emission spectra, okay? Emission spectra. And the second one, we call it absorption spectra, okay? So that's called emission spectra, and also you have absorption spectra. Okay, absorption spectra. Absorption spectra. That's what we have discussed. But emission spectra also can be classified into line spectra. Okay, into line spectra can be classified also into continuous spectra. Okay, continuous spectrum or spectra, and also it can be classified into band spectra. So band spectra. Okay, into band spectra. Okay, into banding. Also you have banding emission spectra. The good news also, we have 3 types of absorption spectra. We have line absorption spectra, and also we have band absorption spectra, and also we discussed about line, about continuous absorption spectra. So in case you missed it, you can access session 4C in our YouTube channel called Tanzania Online A-Level Safety School in square bracket Olenjolai. Just write session 4C, types of spectra from 5 in square bracket Olenjolai. Then you'll get the video and you have to go through it before this one. So today we are learning about hydrogen spectrum. Ladies and gentlemen, say with me about hydrogen, say hydrogen spectrum. Again, say it again and again and again, because this is the very important concept, and we know that we are teaching advanced students this concept for the first time. It's not just like Dalton's atomic theory that we covered in Form 2, or we discussed about maybe the postulates of Dalton atomic theory. That is just a visions. We are just in learning the term, but we have the concept. But in case of the hydrogen spectrum, we're introducing to advanced or high school students for the first time. So we have to take you step to step and build a strong foundation for your comprehension. So hydrogen spectrum. So we have the fundamental question. This is the fundamental question for Sir Olenjolai. What is hydrogen spectrum? Well, so this is a common question that you can even go and search in Google, and we find so many responses. What is hydrogen spectrum? There are so many definitions, but I prefer one of them, and I would like to share with you these definitions, which actually that you have to use in whether you are defining hydrogen spectrum in chemistry or you are defining hydrogen spectrum in physics. This is the definition. So hydrogen spectrums, we say that, let me just start with the word itself. Hydrogen spectrum. Hydrogen spectrum. So hydrogen spectrum, we say that are the all lines in the emission or absorption spectrum of hydrogen, each one corresponding to allowed to unallowed transition between quantum energy level. Between quantum energy levels. So that's the definition of hydrogen spectrums. Hydrogen spectrums are all lines in the emission or absorption spectrum, as I told you in the previous session, of hydrogen. Each one corresponding to an allowed transition between quantum energy level. Later on, I will teach you about quantum theory. And later on, I will teach you about quantum number. And you'll find that it's very interesting because we have quantum mechanics nowadays, and you have quantum in future world, or even that in future we are going to have quantum computers, which actually that will be processing, or will be high processing speed, high accuracy in case of the computations of the particular problem. Okay? So these are the definitions of hydrogen spectrum. So the next question, how can we get the hydrogen spectrum? Right? But the next question, production of hydrogen spectrum. As a chemistry, you are asking yourself the next question, production of hydrogen spectrum. Production of hydrogen spectrum. How do you produce it, hydrogen spectrum? And what the instrument that can help us to see the hydrogen spectrum? Okay? Hydrogen spectrum, simply it is obtained. It is obtained when high voltage, say high voltage, when high voltage is supplied to the discharge tube containing hydrogen gas, is supplied to the discharge. Remember to subscribe, please. That is your own only registration for you. Okay, to the discharge tube containing, a hydrogen gas. At low pressure or at low temperature. At low pressure. This is how we just this is one of the methods that we can produce, or we can obtain the hydrogen spectrum. Simply, we have to allow high voltage to allow the high voltage into the discharge tube containing hydrogen gas at low pressure. Well, that is, so this results the formations of the bright light. So this process result the formation of bright light. So these are the formations of bright light. When the bright light, okay? So when the bright light is analyzed, when this bright light is analyzed, when the bright light is analyzed by passing through a grating, is analyzed by passing through a grating. This is the grating. We are going to learn about grating in atomic physics. Grating using simple spectroscope. So the instrument that we can use is using a simple spectroscope. a simple spectroscope, a series of lines, a series of lines, a series of lines, a series of lines of hydrogen spectrum is observed. A series of lines of hydrogen spectrum is observed as follows. So when we take the high voltage of several kilovolt and pass into the discharge tube containing the hydrogen gas at low pressure, then we are getting the bright light. When you analyze the bright light by passing it through a grating using a simple spectroscope, a series of lines of hydrogen spectrum is observed as follows. So we'll see them. But the way we are going to see them is you'll see series of lines, and this series of lines will have a particular arrangement, but simply you'll see in this sequence. Okay, you'll see the first one from the ground level is called the Lyman series. Say Lyman series. The second one is called the Balmer series. This is the second series that we'll see from the ground state towards the convergence limit. Then the next one is called the Pascal series. Then the next one is called the P-front bracket series. Okay. Bracket series at the next one. And then the fifth one that we can identify is called P-front series. So we're expecting to see the series, P-front series. So these are what we're expecting to observe as a hydrogen spectrum. Just to give you the overview, however, that we are going to draw it in, you'll find that this is the way that they will be arranged from the ground state. For instance, that these are the 5 lines, but you still have some other lines. And then finally you have convergence limit. So this is what we call the Lyman. This is we call the Balmer. Remember that this is a nucleus of hydrogen atom, and all of these energy bands are in the same valence shell of hydrogen. Then we have what oxygen, and then the next one is bracket series. Then we have P-front series. So remember that is from the low energy level to the higher energy level. Okay. So that is how we obtain the hydrogen spectrum. So simply hydrogen spectrum, as we say that these are all lines that we see in emission or absorption spectrum. Okay, emission or absorption spectrum. Okay. So the next step, before even we give you some other names of Lyman, of Pascal, of brackety, because for example, Balmer we call it also it is a visible spectrum. Before we give other names, I want to teach you about one of the key points about the rebate equations, which we are going to use it when we are studying about the hydrogen spectrum. Okay? So, ladies and gentlemen, right now, we are still in the concepts of hydrogen spectrum, but the big picture that we still have. But in hydrogen spectrum, let us focus on the rebate equation. Okay? Let's focus on rebate equation. So rebate equation. Very important equation in general chemistry. Very important equation in atomic physics. Say rebate equation. Rebate equation. Okay? So we have a rebate equation. So simply we say that a rebate equation is the mathematical equation that shows the mathematical relationship of what? Of wavelengths or frequency or wave number of electron in hydrogen spectrum. Hydrogen spectrum. Frequency wave number of electron in hydrogen spectrum, and the atomic number and the energy levels. So that is the meaning of rebate equation. So rebate equation, we say that is a mathematical equation that shows the relationship between what? Wavelengths or frequency or wave number of electrons in hydrogen spectrum. Okay? Hydrogen spectrums and atomic number and energy levels of hydrogen spectrum. That's what we call the rebate equation. So again, you said all spectral lines can be proved on the following mathematical expressions, which is known as rebate equation. The rebate equation is used to prove all spectra or line spectra. With line spectra, yes, all spectral lines in hydrogen spectrum. Okay, so the rebate equations is used to prove all the spectral lines in hydrogen spectrum. Okay. So let me give you the rebate equation. The general rebate rebate equation is given as 1 over wavelengths is equal to rebate constant. We have square of the atomic number, then 1 over n1 square minus 1 over n2 square. So this is general form of rebate equation. So you see that this is wavelengths, 1 over wavelengths, rebate constant, atomic number, the lower energy level, the first energy, the lower energy level, the higher energy level. Okay? So this is in terms of the wavelengths, but remember that speed of light is equal to wavelengths times frequency. So in case you want to determine frequency, we have speed of the light over wavelengths, and this is equal to speed times 1 over wavelengths. So you can consider this one as equation 1. So what is 1 over wavelengths is equal to the rebate is the constant. So we say frequency, okay, frequency of the light emitted by electrons when it jumps from the higher energy level to the ground state is equal to speed of light times rebate constant times atomic number. Hence you have 1 over lower energy level square, 1 over higher energy level square. So this is the formula for frequency, right? Where Z is equal to atomic number. So this is general, not for hydrogen, for any atom or for any element in the periodic table. So let us focus now for hydrogen. The atomic number of hydrogen, atomic number of hydrogen is 1. So therefore Z is equal to 1. So if that the case now, say that rebate equation of hydrogen spectrum now is given as 1 over wavelengths is equal to rebate constant. Hence you have 1 over lower energy level square minus 1 over higher energy level square. Why? Because atomic number is equal to 1. So if you square 1, you get 1. Right? So let me define. Lambda, so where lambda, this is stands for wavelengths in its unity, which is meter. And then RH, this stands for rebate constant. Rebate constant. And its value is 1.096. So the value of rebate constant, this is 1.096678 exponent negative or exponent 7. Okay? then N1 is equal to integer, which represent the lower energy level. Integer, which represents the lower energy level. And N2 is an integer which represents the higher energy level, higher or excited energy level. So N2, this is an integer which represents what? Higher or excited state. Higher energy level, or this is integer which represents higher or excited state. Or excited higher energy level. Higher energy level or state. Okay. So again, we say that from previous session, I told you that wave number, which is V, this is equal to 1 over wavelength. 1 over wavelength. Okay? So it means that the Riemann equations now we can write in terms of the wave number. This is nu. It is nu. Okay, it is nu. That's the wave number. So we can find that the wave number also is equal to Riemann constant 1 over this one. So the good information is the value of Riemann constant. We can get the value of Riemann constant by using the scientific calculator. This is the scientific calculator, cast your function 991, function 991. So you have to press constant 20 Riemann constant. So it is R to infinity. So yes, constant is 16. So you see right now, so if you press constant, the constant button is this one. So you turn on the scientific calculator, this is the constant number, then you press what? 16, then you press the equal sign. So this is 1.0, so you can put in exponential form. It's 1.0973 exponent 7 per meter, but per meter is not printed there. So that's the value of Riemann constant you have to keep it in your mind. So generally, what you have to keep in your mind is 1 over wavelength is equal to wave number. This is equal to Riemann constant. Hence, we have 1 over energy level, lower energy level square, minus 1 over higher energy level square. So this is 1 over lambda, means 1 over wavelength. So this is what you have to bear in your mind. Okay. The next concept now that I want to teach you is the picture or the figure of hydrogen spectrum itself. We have discussed it that when we pass or when you allow the high voltage to pass through the distant tube that containing hydrogen gas at low pressure, then we have hydrogen spectrum. Then if you have the hydrogen spectrum, then we can discuss some other issues. Okay, so we can see the electronic transition. We've got different series of spectral lines in hydrogen spectrum. That's what I want to discuss with you. Spectral lines in hydrogen spectrum. What do you see in simple spectroscopy? Hydrogen spectral lines in hydrogen spectrum. Okay, spectral lines in hydrogen spectrum. Spectral lines in hydrogen spectrum. Again, I would like just to remind you that we have an online advanced library where we have reference books, textbooks, questions and answers books, syllabus, past papers, notes. So you have so many different materials: scientific calculator, original scientific calculator, function 981, function 100. We have them, and we are ready to equip, or we have them in order to equip our students with relevant materials and relevant tools and materials that required for them to master. So you can order them online. Just go to the descriptions, read the description below, you see the link that will take you into our online advanced library. So where that we are going to, you'll see we are going to have this stuff. So spectral lines in hydrogen spectrum. Okay. So this is conceptual chemistry, right? I'm referring conceptual chemistry book written by Dr. S.K. Jain, and this is page 156. So we say the electronic transition which give rise to different series of spectra spectral lines in the hydrogen spectrum. Are shown in figure 4.1 below. So we have dotted line. So these are the spectral lines in hydrogen spectrum. So again, this is suppose that this is the ground state. Okay. So suppose that this is the nucleus of an atom. Remember the concept that if you draw the this is the nucleus of hydrogen. Hydrogen contains only one electrons. So if you write the electronic configurations of hydrogen, this is just to give us one S, which is containing one electrons, or in previous way of writing the electronic configuration, it just into one. So within this shell, so this is the valence shell of what? Of hydrogen. So this is the hydrogen. So within these valence shells, which contains one electrons, we find several energy levels. Okay? So we have this one. This is N is equal to 1. Here we have N is equal to 2. N is equal to 3. N is equal to 4. N is equal to 5. Then etc. etc. And here we have N is equal to infinity. So here we have N is equal to infinity. Okay. So you have to show how electrons transitions is taking place. Okay. So you can have electron transition. First of all, this is what we call the Balmer. This is called the Lyman series, the first one, when N is equal to 1. This is called the Lyman series. The next one, this is called the Balmer series. Next one, this is called the Pascal series. And then this is called the bracket series. The naming is according to the discovery. This is called the pre-fund series. So the transitions of electron is just like this. Here we have that electrons jumps. And here we have another jump. 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 Then here we have a jump. Here electrons jump. Then again here electrons jump. Then here electron jump. Then here electrons can jump. Then again here we are. This is electron jump. Then here we have electron jump. And here again we have electron jump. So here we have another electron jump. We have electron jump. We have electron jump. Then here we have electron jump. Here we have electron jump. There we have electron jump. Okay. So we show these lines, vertical lines, by using arrows. And here we have an arrow. And here we have an arrow. And here we have an arrow. Like that. Okay? So this is figure 4.1. So this is the hydrogen spectrum, the way it is. So when n is equal to 1, we call it Lyman series. When n is equal to 2, we call it Balmer series. When n is equal to 3, we call it Pastian series. When n is equal to 4, bracket series. When n is equal to 5, we call it P-Fundy series. And these arrows indicating that the fall or 40 of electrons. When electrons jump from the ground state, this one, so this we call it ground state. So this we call the ground state. And hence all of this one, we call them excited state. So this we call them excited states or higher energy level. And this one we call the infinity region or convergent limit. So infinity region or convergent region. So called or convergent region. Infinity regions or convergent regions. So all of this one from n is equal to 2 to n is equal to something that before n get into infinity, we call them excited state. And this one, the first energy level, we call the ground state. So electrons prefer to stay in a ground state unless it absorbs sufficient amount of energy, then to jump into the next energy level. Okay, so before we discuss mathematically about figure 4.1, let me clarify to you about or define some terms which are very important for you about ground state, excited state, convergent limit, and also the process of jumping or 40 of electrons. So when electrons jump from this energy level to this energy level, and then it manages to return back into its ground state, then you find that it radiates 40 energy in form of 40 or spectra, and that's the meaning of the first line. When electrons jump from this, from the Lyman series into the Pastian series, which is the 30 energy level, when it falls, it radiates energy in form of radiation, right? And that's what form what? The second ray, means the second line from the Pastian to what? To the Lyman. Same story for the, means that when electrons fall from bracket to the Lyman, or when electrons fall from P-Fundy to the Lyman series, but also remember electrons can also fall from other energy levels. For example, when n is equal to 9, n is equal to 10, into the Lyman series. So we have, we call the Lyman series. We have the specific names for the Lyman series and other names for the Balmer series. So I'm building these foundations in your mind, step to step. So ladies and gentlemen, right now, I would like first of all to define the terminology that we call the ground state. Ground state. Ground state. Remember that these are the nectar or questions from nectar, means that national examination council of Tanzania. Okay, so you find that they're really defining these terms about ground state, convergence limit, etc. So, ladies and gentlemen, one of the fundamental questions is, what is ground state? Okay, when you are preparing for an exam, you can encounter a question that asks you that define the ground state. What it means of ground state? We don't mean about the maybe ground level of the roof. This is a chemistry term. The ground state, it's a chemistry term. So you have a specific definition in chemistry. Okay? So ground state is a minimum. Ground state is the minimum or lowest potential energy lowest potential energy that a particular electron acquire. Acquire in its valence shell. That the meaning supporting of ground state. Okay, so the ground state is the minimum or lowest potential energy. That is that a particular electron acquire in its valence shell or 40 of an atom. So you say that the ground state has the value of n is equal to 1. So this is the ground state. The ground state of hydrogen is also known as Lyman series. So that's the meaning of 40 of the ground state. So according to figure 4.1, this is the Lyman series, or this is the ground state. Okay? Ground state. So we have another term which you call it excited state. Excited state. Okay? What is excited state? What is the meaning of excited state? Excited state is a higher energy level which is below, which is above ground state and below the ionization energy. Ionization energy level by an electron after absorption of energy. By absorption of 40 excited state is a higher energy level. So this is the higher energy level, which is above the ground state, which we have already defined, and below the ionization energy level by an electron after absorption of 40 of energy. Absorption of 4 that remains of 40 of excited state. So examples, we have so many excited states. Okay. Examples of excited states are n is equal to 2, n is equal to 7, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7, etc., etc. But when n is equal to 1, that's not excited state. And also when n is equal to infinity, that's not what excited state. Okay? So n is equal to 1, this is an excited state, excited state, excited state, excited state, excited state, excited state. But this is not excited state and this is not excited state. Okay? Do you understand what am I teaching you? Please tell me in the comment section. So we still have some few terminologies that we have to define about hydrogen spectrum before we discuss the related question in relation to hydrogen spectrum. And these still have two terminologies. The first one is called convergence limit. Okay, convergence limit. And hence we discuss about the other term. So the question in our mind, we have to discuss what is convergence. What is convergence limit? What is convergence limit? Convergence limit we say that is a point at which the electron or at which an electron is completely removed from an atom such that an electron cannot return to its ground state. Convergence limit, simply the point at which an electron is completely removed from an atom such that an electron cannot return to its grounded state. That the means of convergence limit. So the point at which an electron is completely removed from an atom, that's what we call ionization, that an electron cannot return to its ground state. So convergence limit is somewhere here when n is equal to infinity. So when electron reaches there, it cannot return into the ground state, and that's what we get as ionization state. Okay, ionization state. Then the first knowledge that we have to discuss together is called the ionization. Ionization state or ionization level or ionization state or ionization level. So the question is, what is ionization state? What's ionization state? So ionization state is a state of an atom. It's a state of an atom. Is a state of an atom, or is a state or energy level of an atom at which electron is removed, electrons is removed completely. To which an electron is removed completely from an atom. That means of ionization state. So it's a state of an atom at which electron is removed completely from an atom. So example of ionization state is when the value of energy level is equal to infinity. And the value of energy level is equal to infinity. So now I believe that you have understood about ground state, excited state, ionization level, convergence limit. So you know about all of those stuffs. Okay? I would like to spend a few minutes of this session on clarifying instead defining the 5 energy levels. And this is, we say that Weber equation of
spectrum. Give the equation of hydrogen spectrum. Give the equations of hydrogen spectrum. So let us start. So you say, simply say that the Riebeck equation can be used to compute the wavelengths, wave number, image, and frequency of radiated or emitted image by electrons when they jump from excited state to lower state. That's the point that I wanted to make. So for you to understand the formations of this spectrum, of hydrogen spectrum, we say that when, so this is excitation, okay? When an electron in any lower energy level absorbs sufficient amount of energy. So when an electron is in any lower energy level absorbs sufficient amount of energy, then it jumps to the excited state. It jumps to the excited state. So when an electron is in any lower energy level absorbs sufficient amount of energy, then it jumps to the excited state. The excited state, so simply this is, I think that I have to, okay, fine. The excited state is unstable state for electron to stay. The ground state is stable state of electron. Another point again you have to make is when electron fall from any higher energy level, to any lower energy level. Then it radiates energy in form of spectral lines. So when electrons falls, when electrons in this energy level absorb sufficient amount of energy that will make it to jump from n is equal to 1, n is equal to 2. When electrons in Balmer series absorb sufficient energy that can make it to jump into the bracket series, but this is the unstable state. So electrons will prefer to return into the stable state. So in order for it to return into the stable state, it has to radiate the energy which electrons has absorbed when it was in ground state. Again, when electrons absorb sufficient amount of energy that will make it to jump from the Lyman series to the bracket series, the electrons will never stay here. What happens? So electrons will prefer to return into the stable state, which is the Lyman series. In order for it to return, it has to radiate the energy which it has absorbed in form of 40 of radiation. So that's all about 30 principles or excitation principles of 40 of electrons. Excitation principles of 40 of electrons. So we say that when electrons fall from what? From from any higher energy level to any lower energy level, then it radiates energy as it is absorbed in form of 40 spectral lines or in form of radiation. Not convection, but in form of 40 radiation. So the Riemann equation can be used into, the Riemann equations we say that can be used into solve for each electron transitions between any two energy levels of hydrogen atom, a line at a certain definite frequency or wavelength would appear in atomic spectral photo of hydrogens. So, in the next session, I will explain again about what the form of the Riemann equation when electrons get translated or when electrons fall from any energy level into the Riemann series, and when electrons fall from any energy level into the Balmer series, and when electrons fall from any energy level into the Pascal series, and when electrons fall from any higher energy level into the bracket series, and when electrons fall from any higher energy level into the preform series. So stay tuned and join me in session 4E, where I will explain and I will present to you. So the question now, which I have to answer are is the question that's Bose, however, that I didn't teach you well. I didn't teach you yet about Bose theory. That Bose theory hold only to hydrogen spectrum. On the hydrogen spectrum. No. Answer is no. But no, it holds also to hydrogen like ions, such as ions. So we have three helium ion, such as helium ion. So It means that the Bose theory can show the hydrogen spectrums of helium ion, the hydrogen spectrums of lithium ion, but lithium ion, when it ionizes and loses 2 electrons, so remaining is 1 electron, and also the whole 4 beryllium ions. So, and other hydrogen-like ions. So it means that the Bose theory also can explain the hydrogen or the spectrum of helium ion, of lithium ion, of beryllium ion. Remember that the electronic configurations of hydrogen is 1s. The electronic configurations of helium ion is also 1s. The electronic configuration of lithium, when ionized and lose 2 electrons, is also 1s. And then the electronic configurations of beryllium ion is also 1s. So that is about the electronic configuration. So now, to end this session, I really insist you that you have to remember to subscribe into Tanzania Online O-Level Safety School in square bracket Olenjolai for you to get notifications once we upload or we add any new video so that you can go through. So in the next lecture, which is session 4E, I will teach you about the applications of Riebeck equations in the hydrogen spectrum, and also we'll do some computations, some examples regarding about hydrogen spectrum. So you have to stay tuned. So homework. So this is homework, and its abbreviations is H, homework 4D, this one. Okay. So the question is, I'd like to, as I say that, we are also equipping our students with review books. This is Advanced Chemistry Review 1. In chemistry, in Tanzania, we have 3 examinations. We have paper 1 exam. We have Advanced Certificate Secondary Examination, paper 1 of chemistry. And we have also Advanced Certificate Secondary Education Examination, paper 2. And we have also Advanced Certificate Secondary Education Examination, paper 3, which is practical. So this is homework, and just you have one question. Actually, you say that is far. Advanced Certificate Secondary Education Examination, paper 1, okay, 2005. This is paper 1, question 1A. Okay, state the following. State the following. State the following. Roman 1, Balmer series. What is Balmer series? Balmer series. And Roman 2, Bastian series. No, convergence, excuse me. Convergence limit. Convergence limit. But we have also principal quantum number, nuclear fission. But just we are focusing on this. But let me add, state the following, Balmer series. State also what the means of P-Fan series. We'll do correction in the next session. And also state bracket series. So just to do or state these 4 terminologies, which actually that will align you into proper lines or proper alignment of general chemistry. So this is the end of session 4D. I thank God who have created me in his own image and likeness, and I thank God who was with me during the preparations of this session. And I thank you also who have joined me from the beginnings to the end of this session. May really God bless you abundantly until we meet in the next session, which will be session 4E. So you have to be stay focused and stay tuned, and you have to think, how can you take these informations and solve early life problems in your community, in your city, in your country, in your nation? So you have to think, how can you take these experimental information about atomic structure in order to apply for the rest of your life? I remind you, please don't forget to subscribe into our YouTube channel. Again, I remind you to submit this homework. So to ask a question, any question in the comment section. So submit in the comment section, or in case you find that, because this is just a description, later on so I'll give you an email as additional way of you to submit your homework, so I can review and put comments on what you've done. So you have to stay focused, read the description for more information, share these contents with other pre-form 5, form 5 and pre-form 6 and pre-form 6 and the form 6E, and also high school students in any country, in any school, in any high schools, in any private or government school. But share these contents also with the reciters who are receiving the exams at the advanced chemistry or advanced physics or advanced mathematics or basic applied mathematics. So share these information with them. So private students, share with them, or school candidates, you have to share with them. And then you have to keep on praying for me, and I'll keep praying for you. And may God bless you abundantly. But when again you want to offer our living God, who is the God who lives forever and ever, you are feeling thanksgiving, then you may send through that telephone number 0759 745331. So may God bless you until we meet. This is Sir and Engineer Olenjolai Mokotayai Losingo from beautiful country Tanzania. See you in the next session.